the talk that I'm going, it's a long title, but it is basically about one area that is still challenging environmental economists is the estimation of the value of intermediate ecosystem services that are not tangible, that we don't see, and they are not final outcomes and final products. And this work has been motivated basically as a result of the government of South Africa had a very huge development plan. And one major component of the development plan is to develop supporting infrastructure. One of them is develop, harbor development projects. A big one in Durban at the Kwazulu Natal coast. And the benefits, the economic benefits from this large national infrastructure development plans are really multi-sector and large benefits are expected. But the thing is, one component of the infrastructure is affecting a sensitive ecosystem like the Durban Bay estuarine and coastal ecosystems. And to compare really the cost to the benefits of this development project, one will have to be very careful. If you exclude important values that the ecosystems contribute, that particular ecosystem contribute to the welfare and well-being of the people, will be can make a very big underestimation of the value of the ecosystems and the underestimation of the damage that will be caused by this development project. So that was the motive. And so there was a challenge to, first of all, define what are these services of the ecosystems, the coastal and estuarine ecosystems at the bay, and how to value them, especially the ones that are, provide intermediate services that they don't, are not traded in the market as final products. This is a picture of the bay coastal system. Some time ago, 1946, you can see that it has lots of components of the ecosystem, the mangroves and the sand bays. But since that time, the area had seen lots of developments. But in spite of that, you see there is the opinion, the general opinion of the experts is that the assessment is that the bay still represents an important and a key ecosystem, and is really very rich in a number of ecological attributes, especially biodiversity, and is very critical for the fish, the fisheries of that side. And so the task is now to identify the components of the ecosystem, the ecological components, the structure, physical structure, composition, and the functional components that really, the system depends, its function depends on them. So you have the water body, you have the tidal flats, the mangroves, the shore, near shore, and important aspects that we will look at, what they call hydrodynamics, is the exchange of water with the ocean and the open sea, and the flow of fresh water from the rivers as the main source of nutrients. And then the primary production, which is the food chain that is also very critical for the functioning for the fisheries. And then the pollution impact of the developments and the economic activities. We have not looked, you will see that, as an economist, you're going to rely always, when you look at the ecological function and underlying, processes, you're going to rely heavily on what is available in terms of data from the natural sciences, from the ecologists. So this will be opportunistic. So in some of these, we found some data, we were able to look at them. But if natural sciences don't have the data for this, then the economists, nothing you can do Just a little bit on the literature of the on this services of the ecosystems. You know, it has been for a long time that the value of the ecosystem assets and their services have been left out from the development policies and accounting of wealth of the nations for a number of reasons, and that has been considered a major cause of overuse and degradation of the natural systems. One thing that there was for a long time, there is a historical bias in the mainstream development economists' view that ecosystems and their services are luxury goods. They would improve as income improves. The seriousness of the impacts of degradation has not been as visible and important, and attention has been less. Now it's become an important concern. Most of the work of the economic valuation focused on what we call the direct use values of provisioning services, things that are exploited commercially and had, to some extent, market value. But very little has been done in valuing the intermediate services, the supporting and regulating services. Climate regulation, nutrient cycling, and all those things, biodiversity, which had very big value that is missing from all our calculations of value and wealth. And they provide very critical intermediate inputs, as we will see. And this study has used or adopted the Millennium Ecosystem Services conceptual framework, which classified ecosystem services into a number of categories. Provisioning services, these are things like the final products, like the fish, the water, the energy outputs. Also another category of services, called cultural services. These are non-material benefits. And these two, regulating and supporting services, the functions of the ecosystem to regulate a number of ecological processes, and the supporting services of let's say the biodiversity as the life supporting system underlying all these services. These two categories are really the difficult ones to put value on, because it requires that you understand it's not a product that you will sell in the market and find a market or price for it. They are really used as inputs into the production of other final goods and services that are consumed by the economic system and the human society. And so the challenge is to value these ones. One approach that has been used successfully to value these intermediate services is what we call ecological production functions, which model these services as an input or factors of production in the production function. And the ecological production function has, as a dependent variable, the response variable, an output, a final product that is produced using one or more of the ecosystem services as factors influencing the production. And we adopted the production function approach to try to estimate the value of a number of ecosystems, services of the coastal and estuarine ecosystems of the area where the development plans will have effect on. And so our output, the final output that we will produce or produced by that system is fish as food. And also fish, people do, there's lots of recreational fishing at the same time. There's also subsistence fishing, but these are the more commercial services that people get from that ecosystem as a final product. So this is going to be what our model is going to produce, using the structure of the ecosystems that support the production of these. So the final products are commercialized. There is a market for fish, and we can have a price. In the literature, Schaefer and many others worked in this area have modeled the, the fishery production system by, this kind of relationship between harvesting, which is the catch as a function of the stock attributes and effort, economic effort, the E. And here we have the opportunity to bring in the ecosystem services. We see that certain attributes of the ecosystem of the coastal and marine ecosystems affect the harvesting rate itself directly, and some of them affect the attributes of the stock. Now we have a number of stocks. We have stock biomass, stock of the fishery, and we have other stocks that affect the fisheries, and that's where we're going to plug in these ecosystem services, different ecosystem services, and see how they contribute to the harvest of our final product, which is the fishery. We had access to 2 data sets, but they are collected independently and separately, and so we could not put them together as one data set because they are measuring different things. One of them is a cross-section data, very good, rich cross-section data. Has lots of information on the attributes of the ecosystems, the coastal and estuaries ecosystems, measuring a number of components and the state of various components, the physical structure, and the depths of the estuary, the shoreline length, the type of the estuary. They have certain indicators of openness and size of the estuary. They are important attributes that affect the fisheries. The general condition of the estuary in terms of the chemical condition of that, the contents, and then like dissolved oxygen. So they have measures of a number of many attributes of the ecosystem. The data also has information about the compositional attributes, the fish, the biodiversity. So this data set we have exploited. There is another data set that is a time series data set. We also use it in a different to estimate a different production function. And so we were able to then specify a production function for the production of fish biomass. Okay, the fish biomass is the response variable. The fish biomass is modeled as a function of the biodiversity, the compositional attributes of the ecosystem, which is really the number of species. There is information about the number of species. This data set collected information about species, density, and then another attribute that measured the type of the estuary, which is really some classification index, classifying the estuaries into large, medium, open, closed, semi-closed. And this is really very important attribute, physical attribute of the ecosystem that really affect significantly the productivity of the fishery. But at the same time, biodiversity of the fish biology is really affected also by certain attributes of the ecosystem, the estuarine and coastal ecosystem, the condition of the estuarine in terms of the quality, the length of the shoreline, the type of the estuary, whether it's open or closed, and its exchange with the open sea, and then of course the nutrient loading from the river flows. So in this particular model, where we have the cross-section data, nutrient, an index of nutrient condition, a different index, which is calculated as the capacity of the estuarine system, using area indicators. But you will see that we also have another data set, a time series data set on marginal and mean annual runoff time series data that we will use in another model to estimate the flow effect in terms of nutrient loading. And so we had access to these types of data measured by biologists, fish biologists, working on long-term monitoring experiments and coastal and marine fisheries research stations. And so it was an opportunity to try and see, put a value on this. So the system was estimated, because you can see there is some in the unit, you have species, some variables on both sides of the system. 2 stages square was used to estimate. We have tried different functional forms, and we have chosen the one that has, but you will see in the results that the results show all the variables that we had there, they were statistically very significant, and they all have the expected signs. We have found a very strong relationship between the effect of fish biomass of the biodiversity, especially very highly significant, the biodiversity factor, which is species, on the productivity of the fish. And so there is it provides a very strong scientific evidence. These are attributes measured by scientists very carefully and monitored over a long time. And other attributes of the estuary, the openness, degree of openness of the estuary, the condition, the size of the estuary, the physical extent as a habitat, were all very important, very significant factors affecting the fish productivity and biodiversity in the system. And we were able to measure their marginal contribution to the productivity of the fishery, directly and indirectly, directly on the harvest, and indirectly through the affecting the other attributes like species, richness and density. And so with this we can calculate the total effect made of the direct effect plus the indirect effect for the ones that are working on the species, for instance, indirectly and directly on that. And then we can just, because we know the price of the fish in the market, we can just calculate the value of marginal product, which will be the marginal contribution of these different attributes of the ecosystem. And so we can give the people who are doing the cost-benefit analysis of this development some idea about what value are we losing by damaging the ecosystem and the functions of the ecosystem that is supporting this. So this is one way. So far it's been probably the major approach to value intermediate regulating and supporting services of the ecosystems. But then, as I said, we have access to another data set, which is a time series data set that is collected also by specialists in this area in the coastal and marine sciences. The data had provided us an opportunity to look at the functional attribute of the system, the nutrient loading from the runoff river flows into the bay, and also collected information on spawning patterns of the counts of fish, egg, and larvae. So we were able to combine these data sets and estimate the effect of the flow of fresh water into the estuary through productivity of the fishery in that ecosystem. So the relationship between nutrient influx and the count of fish, egg, and larvae, and the nutrient loading, especially particularly for the Durban Bay, which is considered nutrient deficient region because of the marine scientists have their criteria so that's considered a nutrient deficient system, water system, and so the inflow of fresh water with the nutrients it brings is very, very critical for the productivity of the fisheries there, because it's really the affects the spawning, the young, and of course the the predator fisheries that feeds on the. So it's very important for the for the food chain in the system. And we, because of the nature, and this is people who are specialists in this know better. There is a suggestion that there should be a lagged effect of the flow of water and nutrients into the system because of the spawning periods of the younger. I think they talk about 12 to 24 months of spawning. So we tested for lagged effects. And we found that they were actually very significant. The 1 period lag was not statistically significant. The 2 period lag of the flow was very significant statistically. So we just reporting those two. But the model has been estimated with 3 lags, and we tested 1 lag, 2 lags, and 3 lags. These are the most significant ones. And both testing Cobb-Douglas forms and linear forms. Linear form gave the highest statistical significance. Very high explanatory power to the productivity measured. Actually, not really the biomass of fish, but they measured in this particular. The data was measuring the density of larvae and egg of the fishery. They think, the scientists, as I said, they think that the lag effect makes sense because of the fish biology, that they understand the system, that there should be a lag effect because of the cycle in the productivity of the fish. And so, they said the significance of the lag effect is really consistent with their knowledge about how the biology of this system functions. And so, we had this opportunity of these data sets we were able to generate through the production function, the value of these ecosystem services that are hidden, that you don't see, they are not visible, they are not tangible, they don't know market for them. Usually are ignored in the evaluation, in the wealth calculation. They just ignored completely, but they have very high value, and then it gives you information that you could use for policy making and for a number of other purposes, like doing cost-benefit analysis of development or policy change development project. So there was results that are of importance from the perspective of the science, that there is a strong relationship between the attributes, the composition, the biodiversity, the species richness, and the productivity of the fish. The other attributes that are, physical attributes, functional attributes, like the nutrient loading from fresh water. But then, especially with the biodiversity, what happens is it indicates to policymakers that there is a big value that you lose. There is evidence that you don't, you should not ignore, which is the value of the biodiversity that we don't see as tangible, a product that we consume or use directly. So it's a signal for policymakers and development planners that they have to be very careful with interfering with the ecosystem without paying attention to these services. So development plans must really, especially in sensitive systems like that, they must really pay attention to the damage, to the underlying functions of the ecosystem, and should minimize those damage, or have, so always think about a mitigation mechanism or ways to really reduce that's very necessary to reduce the damage that's caused, because there is a big value that you lose if you don't pay attention to those. This information also can be useful for the fisheries policy and regulation, especially with fishing permits, because the practice in designing fishing permits and licenses is based on information about fish catch, the record of the past, the record of fish. It's always the case typically that the countries, there is no country really have information about the stock of the fish. And so the information that they usually use for management and policy making is really the catch. And they use the catch actually to estimate, to have an idea about the stock. But this gives also another piece of information that can be used. You can use attributes of the ecosystem, like the ones that we have measured, the relationship between and the productivity of the fisheries, can also be a useful information for the management of the fishery and policy about the fishery, especially permits for fishing. Okay, because you can use that as predictors of the fish stock as well. And you have information about how the system functions, the spawning, the periods, and the effect of the nutrient loading from the river flow, which is also another useful relationship that will allow us also to assess plausible impacts of climate scenarios of the future, impacts on water flows or the coastal systems. So hopefully that especially the relationship between the nutrient loading and rainfall or runoff with the fishery productivity is very significant, highly significant. So people need to take that into account and pay attention seriously to and can be used to model prediction of the impact of, as I said, climate change implications for the productivity of the fisheries and the well-being and the economic impacts on people who depend on that resource, for instance, for living or commercially. As I said, we can put a value on these services, what we call accounting prices, which we can use to estimate the progress or performance of economic systems or social systems are usually measured. This is one other problem with indicators of economic well-being and performance. You measure that by GDP, but there is now attention is changing to better measures of welfare. Change in welfare is really measure the change in wealth, not the change in income. Because if you can achieve very rapid high growth rate in GDP at the expense of liquidating your natural asset, natural capital, as you know. So the better measure is to look at how your wealth is changing, and that wealth, the definition of wealth has been expanded to include natural wealth. In the conventional economic accounting systems, we exclude many of the high value elements of our wealth, which is the natural capital. So by having values of the services that we get from these assets, we can put a value on the asset itself as a natural asset. We are able to improve our ability to estimate our wealth, total wealth, inclusive wealth, including natural capital. The one limitation of this study is that we have, because of lack of data on economic effort that is consistent with the data from the marine and coastal biology and physical attributes to put together, you will see that our models did not include the economic effort. And so, because we have not accounted for that, these values need to be, considered, with caution. They at least provide boundaries, upper boundaries of the data. But then, which is actually the more available data, the economic effort, you will find that data, and we are actually getting data on economic effort. We're going to try, then control for the effect of the economic effort. We have information on catch, and now we're getting information on catch, and some measure of the economic effort like crew, numbers of crew, and hours of fishing. So we'll try and collect, but still, this provides some, upper bound, an upper boundary for the types of values that this ecosystem has. And then we're also going to consider this is a difficult thing with the fisheries because you don't have information on stocks, but people have. And these models are, transformed to have to estimate the stock, change in stock and stock dynamics. If we have economic effort and harvest, and that's one thing that we're going to try and do. But you can see that to be able to do this is tough. You have to understand the underlying, the structure and function of the underlying ecological processes. Without that, there is, we as economists, there is nothing we can do. So it is very important to understand that, and to understand that you need help from the specialized sciences, whether it's forestry or fish biology, but it's the economics part probably is the easier part. The difficult part is to get this information from the ecologists and scientists. But you need to work with them to be able to do this. Thank you very much.
Rashid, would you like to settle down here for a few questions? Well, thank you. I remember visiting Durban Harbor. Took a tour of the huge sugar terminal, I think the biggest of Africa, and we had some fish at this harbor restaurant, where they always ring a bell when a boat comes by, and then they say, "Oh, ship so and so on its way to China or Korea or Hamburg," and they were ringing the bell, and everyone looked out of the window. There was no ship, but the family of dolphins were swimming by into the harbor. So it dawned on us this is a very special ecological area. I think the relevance of this work is tremendous. You emphasized a number of analytical and conceptual innovations, and let me throw it open, and colleagues may like to also have a clarifying question. I have a little one maybe later on. Could you come back to your empirical findings? How big are these intermediate effects? From the quick look at the parameters, I couldn't catch that, but maybe that's more an empirical question. But colleagues, feel free to ask questions.
Yeah, maybe as you are thinking about it, I can just have a quick response. The estimates, we were not really interested in comparing, and it's usually that the economists, they calculate the economic benefits from these big projects. They are huge, especially when it comes to things like mining. The minerals have very high value, and the damage, if you're damaging a forest ecosystem or whatever you try to do, that you cannot really match that big value. But it provides information to the policymakers that this is what it's worth that you're going to lose, and so you must be willing to invest at least that much to protect the environment, whether to think about mitigation mechanisms. For instance, in this case, this study provided information about the value of water treatment, for instance. And so that was used to compare the cost of water treatment, for instance, the work on the pollution. As I said, information about how the system functions and how you can design policies to manage the fisheries. How you can modify the harbor development plans to mitigate these effects and you know, reduce as much as you can the damage. And it gives the policymakers or, you know, environmental activists piece of information to tell the government this is a price that you must pay, or the taxpayers or whoever is benefiting from the development of the policy change. So it doesn't necessarily, you know, support the cost-benefit analysis as which one is bigger or the returns are bigger, but at least, you know, make the policymakers and managers aware of the value that the society is losing with respect.
Mm-hmm. Okay. Yeah.
I have a question. I have questions for the context, and then.
But don't ask me questions about the fish biology because I'm not a specialist.
No, actually, it wasn't clear. I mean, this is just a context. It wasn't clear what this development plan actually sets out to do. So you showed us a picture from 1946. So I'm not sure how it looks like now, and what the development plan actually wants to do, and how. So would this estuary ecosystem completely collapse with these plans, or would it only be affected? So this was concern. And then a few technical questions. You said at some point, it probably doesn't really matter, but you said that the harvest is a function of stock and effort.
Yeah.
And then the development plans or changing the ecosystem affects harvest directly and stock. But if harvest is a function of stock, how can it then be directly affected? You said that in one of the functions, well, what you modeled was biomass, and biomass increases also with the diversity of species, which I understand. But for the fishery, isn't it what matters? Is it not the biomass of the species that you're actually interested in, and not total biomass? So I can see that total biomass is positively affected by species diversity, but not necessarily the biomass that is interesting for the fishery.
Mm-hmm.
And then concerning the results, didn't you show that not treating your runoff, so having actually nutrient loads in the water and polluting the bay, didn't you show that this has a positive effect on biomass? So it's actually good to have dirty water run into the bay in terms of fishery?
Well, that's
Sure.
it's quite
Yeah.
a load.
No, well,
Questions?
I have the actually the description of the development project. It's a huge, massive. It's going to change the structure, the whole structure of the bay. You know, they are expanding the harbor facilities along all the components of the bay. So it's a huge intervention in the system. It will change, and I did not, because I thought I would not have time to describe and talk about the project, but it's a huge project, and there are lots of other studies that went on this, so I just told you one small story of that. With respect to the functional relationships, there are some attributes of the ecosystem, for instance, the physical structure, because it provides habitat for the breeding of the fish. So it affects the fish biomass directly. But at the same time, this and other attributes affect the fish biomass indirectly by affecting the diversity of the species. So there is an effect, direct effect on the biomass of the fish that you catch, and there is an indirect effect, that's an ecological effect that is affecting other factors that affect the productivity. So that is the meaning, because if you see the system has some attributes affecting the fish biomass, the catch, straight, and some of them affecting the species diversity, which is affecting the fish biomass. So they work through impact on the diversity of the fishery. So there are, there are probably other relationships that we have not modeled here. So for instance, the physical structure probably affect the indices of condition, the dissolved oxygen, the interactions probably are more complex than the ones. So some of them work directly, some of them work indirectly through other factors. But they are all components of the same system. And for instance, the biologists and the scientists working there are the ones who would suggest, they know the science behind how the physical attributes and the functional attributes like the loading of nutrients affect the species diversity and the spawning and different recruits of different fishes at different stage of their life cycle. So there may be even more complex biological relationships, but some affect directly and some indirectly. And I'm not sure what you mean by total biomass. We have not looked at total biomass, looked at fish biomass.
Well, I mean fish biomass.
Yeah.
Total fish biomass.
Yeah. So, but you're saying that is what we should be measuring, right? And that's what they measure.
Well, I understood that you measured total fish biomass, and my concern, or my question is if you want to measure fishery relevant biomass, then it may not be the total fish biomass that matters, but only the fish biomass of the relevant fishing species.
Well, you're talking about the different species.
And their price.
The different species of fish.
Yeah.
Now there was no information about speech by speech. It's the total fish biomass and the total diversity of the fish biomass. So the number of species, that's what they have measured. So the relationship is how diverse are the species in that population, and how is that related to the productivity.
Okay.
So that is the way they have measured the composition, which is a diversity index. They measured the number of species, how many different species, and that is a general, typical measure of biodiversity, species, number of species. So that's one measure that and that was only a piece of information about the biodiversity. Now the nutrient loading, that's exactly what we are saying. We are saying that the nutrient loading is beneficial to the fishery. Now the harbor development will cut the feeding or the flow of the, one of the impacts will divert the flow at least and will cut the flow, which is the blood, you can say, because that is very important for the fishery productivity. It's not negative, but maybe you have confused that with the water treatment. But the water treatment was looking at something else, that the pollution part of, and that's a different story. The development of the harbor is expected to have certain pollution effects, and especially on the water. And so there is work that has done compare cost of water treatment versus the benefit from the. But that has nothing to do with the flow, the river flow. The river flow is one function of the ecosystem that is beneficial to the fishery, and the development will intervene with that and affect that function of the system, the loading of nutrients from fresh water.
Okay. Okay.
I've seen from your presentation how you calculate the value of these intermediate services in the current activity going on in the bay. Do you have any way to estimate what the impact of the development will be in decreasing the provision of these intermediate services, so that you can then value the net loss in terms of the fishery industry?
Yeah, the whole project did that, you know, but that's a huge thing. See, you know, there are components work that have identified the likely impacts of this development, and I have not talked about that. But then, you know, then they were looking. So they were looking for how do you put a value on those services that are going to be impacted on, and we have done the part to give them those values, you know. But then they have estimates of even the extent of the impact. Also, to come back to your question, so the specialists, you know, from engineering, and you know, they have estimates of even the size and the magnitude of the impact on the different components, whether it is mangroves or the coastal line, the shoreline. But then the part of the ecological economics say okay, so if you're going to damage the mangroves by this, or the tidal flats by this much, you're going to reduce tidal flats by you know, how many hectares or kilometers. This is the value of that change or that intervention. This is the ecological cost of that. But you know, I have not told you the full story about the development. The development project, I did not tell you anything about. I just you know, gave you the story of the one component of that, because the economic benefits, people, they have done a CGE model and have estimated the economic benefits of this harbor development to the entire economy. But I also haven't told you about that. It's various components. But as I just said, there is one component that is usually ignored when you do these calculations of cost benefits. They calculate employment, you know, effects on income, other sectors, the multipliers, but then the loss of value from the damage to the ecosystem is usually the difficult one, and we try to estimate some values.
Good.
Thank you for your presentation. I have two questions. One question is related to the institutional part. Let's say these values are assigned to these ecosystem services, so how it will be functioning, yeah? Who will collect it? How it will be through compliance market, or through some voluntary market, or it will be some kind of rewards from state to the, let's say, fisheries or users of these ecosystem services, or providers to these ecosystem services. And
Yeah.
Second question is related to trade-offs or the provision of ecosystem services. Yeah? I'm sure there are also negative correlation. Enhancing one ecosystem services will lead to the reduction of another. So maybe you capture it.
But can you repeat that again? I didn't get the second question.
Second is related to the trade-offs or the provision of ecosystem services. So for instance, expanding the supply of one service will lead to the reduction of another ecosystem service. So whether you capture it or...
I understand what you are saying. The first one, of course, you know, you must be aware of the payments for ecosystem services schemes. And if you want, I mean, that was not the issue for this particular. If you want to establish a system for payments for ecosystem services, then we have information about what that value is. So, the study was not about establishing payment for ecosystem services to compensate, but there are lots of aspects of that. Usually, the beneficiaries will compensate if there are, that would be a situation if there is that kind of trade-off. For instance, let me give you an example. If they want to develop an irrigation scheme, okay, upstream, which will affect the water flow into the estuary, which will affect the nutrient loading, which will affect the fishery. So you have two entities here: the fishery, the fishery sector, and the irrigation agriculture sector. They have to talk and establish a system of payment for ecosystem services. So the irrigators must compensate the fisheries, or the fisheries must compensate the irrigators, or that kind. But this was not about that. But if there is that situation, the fishers can say, this is the value that we need to be compensated for, because this is the type of damage. You are affecting the nutrient loading, you are affecting the productivity by that much. So this provides the substance for them, or the indicators, or the instrument to negotiate. But this was about this intervention. The trade-off here is this intervention is going to produce, also economic benefits are part of the ecosystem services, the provisioning services. But that is the trade-off. You increase the production of economic benefits through expanding the infrastructure, increase the economic activity, and you produce more consumer goods at the expense of other ecosystem services. These are the regulating and provisioning services. So that is the trade-off that is considered here. Of course, by expanding the infrastructure, increasing the economic activity, benefits of employment and income and production of consumers' goods, whatever, and use of energy, those are going to increase, expand. Those are provisioning services, more food, more whatever. But then you're going to reduce the supply of this other ecosystem services, and that is the trade-off that we look at. If that answers your question.
Quick last set of questions. Let's collect them. Alicia. Okay, I see two more. Go ahead.
In the context of this comparing economic benefits of development, harbor development, and the losses from ecosystem services, you showed in the example of fishing, and also there may be other sectors which are benefiting in parallel from the same services, and the values would be added up. But my question would be, there may be some other benefits from these ecosystem services which even now ecologists or fish biologists don't know about, and they can be very valuable as a whole, and we don't enter them into the model. And in that context, what would be your advice to a policymaker about this decision on both aspects, especially to the ones which are facing this earlier stages of the Kuznets curve to which you referred, and they have many other priorities, maybe perhaps in addition to environment?
Maybe we collect the last two as well. Jimmy?
Yeah, it goes a bit to the direction of Alicia. I was thinking about the sustainability of the different attributes of the ecosystem services. For example, the values that we get today, obviously I think the value will change in the future. How, the same direction, the type of advices you also may give to capture this type of uncertainty, which can be linked up to the calculation of the value. And my second question is related to, I think when you use the time series data, and you introduce the time lapse, if we have, let's say the mean annual model, and we link it up with the fishery eggs, I assume that that time is capturing other activities happening during the different process of the runoff. How would you think that we can capture that? Because I think the time is just giving information in two different periods, and within the period a lot of things are happening. They are biological characteristics, they have biological characteristics, but also economic characteristics.
So yes, last one.
It's more like a comment. So I think the challenge is not only the partnership with natural scientists, but also to have this data available, because what you showed is that you had ecological data for 72 estuaries. So you need fishery information or species diversity for a really big number of estuaries in different conditions with different characteristics to actually model something from this. And if I think about, if I want to connect this, say, forest and flooding control, for example, I would need to go around having flooding data and forest types and slope and all these different information for so many different sites in order to actually be able to make a model. And that is maybe an even greater challenge than cooperating with natural science.
Yeah. I will start from, is that all?
Sure, sure.
I will start from your comment. And if you noticed on my slide, that was one of the major implication of the study. The importance of having this long-term monitoring activity like the ones that generated this data. Okay, because this data was coming from, and so one of the implications and the conclusions of the study indicates the importance of this because it allows you to do. And that also comes back, what I'm going to say basically starts answering, responding to your question. The complexity is a fact. We cannot run away from it. No matter how much you're going to measure, you're still missing some components. So these things are so interconnected. You can't say, well, I can't measure this component in the forestry runoff system, and so I will, that's not important. You will always have, limitations in terms of how much you can capture in terms of these processes, but you have to take into account this complexity. The one thing that people do, and that common practice also comes back to your question, is that there are, there are rules that people use when you have, these things are done usually with, measures of levels of confidence. So if you have very high uncertainty about something that is sensitive, like biodiversity, for instance, there is this rule that people use for conservation that, if you're not sure, don't touch it. And this is a very, reservationist strategy. Set aside 10% of the forest, as conservation area. These are rules because we are not sure what are the future impacts and what are we losing, because there are things that value of biodiversity, for instance, in this forest that we know now, but what we don't know maybe even of higher value. And so, this is a general rule that people, in the case of very high uncertainty risk, the thing is to conserve, don't touch, don't interfere with the, and this is, there are different sustainability strategies, that strong sustainability arguments that many people say, we run the risk of moving this system to an irreversible situation, so don't come near it. But also, I talked about only the fisheries and the ecosystem, the coastal and estuaries ecosystem. But as part of this, there are, the other pieces of work that have estimated even recreational value, educational value, and cultural value of the bay. So many other, bird watching values, lots of other components. I have just spoken about. But even all of those, of course, the pollution component is another component, the environmental quality. But all of those, when you add them up, you're still missing a lot, as you said. We don't know what else that we are losing, and so these recommendations are basically warnings against what kind of risks we have. But usually they don't prevent the development. The purpose of these studies are to draw the attention of the development plan to sensitive areas that they must make sure that they don't damage, or design mechanisms to reduce the kind of damage that will happen. So it's to be careful with. It's not just free that you can do whatever you want to do. And the sustainability of the future values, of course, the idea of a prudent management of any system or ecosystem, that's what the ecologists will and the biologists or forest scientists will, they do they do always emphasize the sustainability aspect, that if you keep the system intact, you don't interfere with its components, or you don't interfere with this in such a way that you will flip the system, then that is there is a management strategy for the system for its sustainability. And when you when you generate information about this is how the system functions, and if you interfere this way, then you're going to change the services that we get from the system in the future by changing the attributes of this asset. And so you draw the attention, and as I said, there are a number of pieces of information here that would be useful for instance, issuing fishing permits. You can combine, for instance, the information from the runoff. You can predict what will be the condition of the fisheries next year, if depending on how much rainfall, for instance, so it can help making management decisions and plans. Also, it's one or two indicators of the potential implications of changing the climate, in the stream flow. So you're generating bits of information about important components, but you're not having full information about each and every element of the system. So, for instance, you say there is lots of things happening, but as I said from the beginning, this model, one important element that is missing in it, even very critical for the production process itself of the fishing, is the economic effort. So we're trying to get information because the harvest is a function of how much effort you put into the fishing. So these are not perfect models, but at least reveal information about the emphasis of this is really about this ecosystem is going to be impacted upon heavily by this development. And what are we losing? We just want to have information about what is it that we are losing by this damage, and a little bit of information on this.
Well, let me conclude with a couple of remarks. Number one, the world will build dozens and dozens of big ports in the coming decades. So this is very relevant. To look at the indirect effect and at externalities, both on the benefits and at the cost side. Secondly, because we have so much deeper insights on externalities of infrastructure, the indirect benefits spreading through society, the indirect costs through the ecology, I think we're alleviating the game. We get more sophisticated on both as economists, on the cost and on the benefit side. Old-fashioned infrastructure benefits cost calculations of travel costs and travel cost reductions, of course, are completely outdated. So we have that progress there and there. I wonder how it will impact on what development investors then really will do, that increased sophistication. And on a somewhat mocking note, Germany has just opened half a year ago its $1 billion project of a new deep sea port in Wilhelmshaven. It costs about $1 billion. The ship didn't come. It's a much disputed misinvestment because number one, international traffic has come down, and number two, the traditional ports have improved their services, Rotterdam and Hamburg. So we have a beautiful 1 kilometer plus new quay of 16 meter deep seaport with all the equipment. The lesson, there were several questions. Is your analysis leading to thumbs down or thumbs up, and so on? Sometimes there are surprises, and usually my hunch is the overestimation of the benefits relative to the underestimation of the costs, and you add on the cost side. Let's hope that the harbor is designed in such a way that it makes sense, and that the wonderful ecosystem which you have there still works out. Maybe one can also redesign a little bit. Rashid, the train which you will take to the airport this afternoon will go through a number of tunnels.
Yeah.
They have been dug because there are some rare birds in the forest on top. They've cost us a few hundred millions. I'm not suggesting that you redesign the Durban port area to protect all the birds, but as a bird watcher, let me close with that. It costs money, but sometimes society has a willingness to pay. I don't know about the South African society. So your talk relates to our country, and comparing notes with what you do there around Durban as one of your many, many, many projects, and what we do here in Germany. It's one word, and thank you very much again, and let's